Hi, my name's Ian Gardner. In this demonstration, I'd like to show how Watson Visual Recognition from IBM can distinguish between a reference perfect object and objects that have differences, maybe marks, maybe different shapes, things like that. Watson Visual Recognition is available as standard within IBM's Bluemix DevOps environment. So you can go in there, you can demo it, you can try it. It's very, very simple to use. So here goes. So this is Watson Visual Recognition. This is the demo of it. So it's not the full-blown system, but let's see what we can do with it. So to start the experiment, I've taken a number of photographs of a Lego model, and each of these images is of a different angle. Rotating the model. This is what I've classed as a perfect image. Not that the photograph's perfect, but the Lego itself is perfect. It's got no missing parts or anomalies on there. But I've also taken some photographs of the model with anomalies. So let's have a look at that now. So we can see here that in this picture we've got a piece missing, and that piece was here. We've got, if you look over there, we've got the button on there, whereas I've took that off this image. And I just would be interested to see whether or not that Watson Image Recognition could see that that piece was missing. And I also did some other things as well, so let's have a look at those images. So here's an image where the rear end of the model has been lifted up, so it's out of position, and we could say that that's an abnormal view. Again, multiple pictures in different positions. Then finally, I've altered some of the images. So if we look here on this picture, I've added some scribbles to the digital image. Similarly here, there's a black line which I've added to the white plastic to simulate a mark on a part or something, just to see whether the system could recognize those differences. So before I start looking at my images, I just thought I'd do a quick test on a general image using the general demo system, and this shows how the classification can work. So anyway, I did a quick Google search, found my my current car, the Ferrari, I wish, and I'm going to take a copy of that location, and I'm going to paste it into the general service. So let's have a look. So do some analysis now. And this is what Watson sees. So it's quite interesting. It can see that it's a coupe, which is good. It's only got 2 doors. But it's a car, so it's quite confident. You notice the score ratings. These are based on probabilities. And that's the way you look at things as a human as well. So I can see it's 87% probability if it's a car. It's a vehicle. It's definitely a vehicle. But this is interesting. It can tell that it's a sports car. It's pretty sure as well, 97% probability that's an ash grey colour. And we can see here that it's created a hierarchy for that. So you can see it's a vehicle, coupe, sports car, which I'd say is pretty close to what we've got. And you can see here that we've got the JSON output there, which you can use in our analysis. So all the probability scores are in there along with the class, etc. And we can see the hierarchy as well. So now let's try my images let's see what Watson can do of this. So rather than going in the try mode, which looks at all the general stock analysis and the stock training that's in there, let's click on train. Like I say, this is the demo system, which is not half as powerful as the full system, but it gives an idea as to how it works. So I'm going to click on use my own images. And here we've got positive classes. So these are the images which we're saying are recognizable. So I'm going to add my images or classes, and these are positive classes. So here we go. Let's add these images. So here I've got a number of images that are the correct images. They have to be zipped to go into the system. So I've done is taken all because I've got quite a lot of photographs, I broke them down to front, left, rear, and right. So let's take the front view, add that, and you can see that it's called that the name of our zip file, perfect front view. Let's add a perfect left view and a perfect right view. Okay, it's a Lego model. Now I'll quickly train this. Okay, so we've got all the images in there. We've got positive right view, positive left view, perfect front view. I'm going to add the rear class onto this now. So perfect rear view, the zip file, as I said. And then I'm going to retrain it. Right, so I've got a full 360-degree view of my perfect model now. That's all loaded. And if I wanted now, I could do a test on a particular image that I've got. So let's just try that. I've got no negative views in there at all, so let's have a look. So if I say take that image, for example, let's see what happens. Okay, so it's analysed that image and it says it's a perfect front view of the Lego model, and it's given a 97% rating, and it also asks for feedback as well. So if that was incorrect, I could click on no to train the system. I'll say yes. So that's proof that we can recognize a perfect image, but now I'd like to look at how it can identify that pieces are missing. So I've got a negative image here. So this is a negative class, and these are the images which don't match the what I'd class as perfect. So I can click on that. Let's find my images. Just bear with me. So piece missing. It has to be a zip file. There's quite a few pictures in here, and I'm going to retrain this. Okay, so it's got those images in there now for negative classes. And let's see what happens if we add an image with a piece missing. Let's find one. So there we go. There's the piece missing. And let's see what it says now. So here, despite it being a perfect Lego model, or you can recognize this Lego model, it's saying something is wrong. So basically, it's only got a threshold of 0.5 based on the training provided, and that's just because there's a piece missing. So I'll say, yeah, that's correct. And now I'm going to try a similar image, but with that piece on, and just see what happens if I had the normal picture. So let's go back into the correct images, and that was the right view. So there we go. There's the same one. It's got the piece on there. Let's see what happens. And again, yeah, it said, yeah, it's perfect right. 96% score. So that's pretty good. It's recognized that there was a piece missing. If I'd have put that piece missing in as a positive class, then it would have recognized it as a piece missing rather than as lowering the probability classes. So as a quick experiment, I'm going to add a marked image to see whether or not it can identify that there's a difference between this and the perfect image. Now, I've not trained this image into the system yet, so let's see what happens. Let's find my images. So here we've got a similar image. That was the piece that was missing before, but we've got this mark here. Let's see what it thinks of that. Yeah, this is interesting because it's still recognised that it's a perfect right view, even though it's got the mark on there. So let's see if we can retrain it to look for marks. So let's see what happens. Say no, that's not correct. There is a difference there. Needs more training. Let's add another negative class, and this is going to be the two damaged items. So we've got this zip file here, which has got damaged items in there. So let's retrain it. Okay, so we've added some extra training. Let's add that marked image again. Let's see what happens. So now what we've got is it's saying, yeah, it's a right view, which is correct, but it's saying that the probability is much lower, and that's because of this mark on the model. So that's correct. So each time we're training the model to learn what the differences are. Let's try the perfect image again. Let's see what it brings back with that. So let's find it. Here we go. Perfect right view. So same image, but without the mark on the side. So yeah, it's now saying the probability is higher. It can recognize that there's no marks on there, and that's correct. So now I'd like to try a bit of an experiment to modify this image. So this is the perfect image. I'm going to put a mark on it. So I'm going to open it with Paint. We can see the image here. And what I'm going to do is I'm going to add a mark onto that. So there we go. I've added a circle. We've not had that before. I'm going to save it. I'm going to call this circle. Save that. Close that down. So here we go. There's the image with the circle on there. So we've not had that into in the system yet, and let's see what the system makes of that image. So here we go. Let's add the new image. Let's find there it is. That's the one with the circle. Let's see what happens. So there we go. So it's never seen this image before, but what it has identified is that it's the right view, but the probability score is much less. So the system is starting to learn, which is good. Now I did have some images that were out of position where I lifted the back end of the model. So what I'm going to do is I'm going to add those as a negative class as well, because they deviate from the perfect image. So let's out of position. So there's a number of images in there. Again, zip file. Add that and retrain it as negative images. So these are deviations from a normal. Right. Okay. So that's trained. Let me add a out of position image now. Let's have a look. It could be any of these. There we go. We can see the back end's up compared to the normal. Let's open that. And again, yeah, it said, well, hang on a minute. I know it's there's something wrong here. The threshold is 0.5. So it didn't recognize that. So now let's just, as a final test, add the correct image just to see what it makes of that. So correct image on the right. There we go. So this time the back end's in its normal position. There we go, 98%, and it's saying the perfect right view. So yeah, I think that's a pretty good test. This is the demo system, which is not half as powerful as the full system. You can look at the JSON output from this, and we can see that it's a Lego model. It's a perfect right view, and what the probability is just under 98%. So I think that's a pretty good test. If we were do this in Bluemix, then what we can do is we'd create classifiers, etc., and we create APIs to feed through the system. It can be used through Node-RED as well. As a final test, I'm going to add something completely different, just to see what it makes of this. So the Ferrari, which I looked at earlier, I'm going to add that, see what it makes of that, see whether it can understand the differences. I'd like to think it will say that's nothing like the Lego model, and sure enough, yeah, it's I say, no, I don't know what that is. So there you have it. That's a very simple demonstration of IBM's Watson image recognition. And here I've tried to show how Watson could distinguish between a reference or baseline object versus objects that don't meet that perfect criteria, or it could be anomalies, could be scratches, could be anything like that. My name's Ian Gardner. I hope you found this useful. Thank you very much.